Hey guys, how's it going? So today we're going to write an ECS, or at least start writing an ECS in C++. Now, if you didn't see my previous video on ECS and its architecture and the building blocks required, then I'd recommend going to watch that, and I'll put a link in the video somewhere, and then you can come back here and start implementing along with me. I did try and record this video before, all in one shot, and it ended up being over 2 hours long, which just isn't digestible. So I've decided to re-record it and split it up into kind of 3 or 4 different videos. 1 introduction and entity manager, 2 component manager, 3 system manager, and then 3 will also include some kind of helper utility classes to really improve the developer experience, or I'll do a separate video, but I'm just working that out at the moment. With that being said, let's begin. Alright, so here we go. Now, let me know in the comments if this size is okay to kind of view this video at, and people on phones and stuff might not be able to see stuff, but hopefully it's okay. I've tried to kind of zoom in. So I've got a blank project here, just a blank CMake project. Source include, I've chucked a Clang format in so that we can format, and we're going to use CMake C++ standard 20, so C++ 20, and we export some compile commands for ClangD. Let's get going. So if you remember previously, we said that a entity could just be an ID, right? So my entity ID could just be that. And this is fine, but let's say this was an animal ID, and then we also wanted a human ID. Now, these two things, if we made a function, could be compared. And then something could, and this would work. This is perfectly acceptable. But really, you shouldn't be able to compare a human ID and an animal ID because they differ. They're 2 different kind of species. So we need a way to fix this. We need a way to kind of have a typed ID. And the way that I do this in EV Engine, for example, is I have a class called ID. And this is a templated class. And the reason why we do this is so that we can tag the ID to a specific type. Now that might be, for example, entity tag, and we're going to alias an entity ID to be ID size t, and then entity tag. So this works nicely because now we have an ID that is aliased to an entity tag struct, and then we could do the same. For example, we now could have human ID size t, human tag, struct human tag, and then we need to actually populate this class. So t is going to be the type of the ID that you're using. So we can just, all this class is going to do is hold an integer effectively. And then we also want to be able to construct the class like that. So now we can construct this ID type. And then to make sure that we can kind of properly compare, what am I doing? Properly compare kind of 2 IDs of the same type, but also not get 2 IDs of different types mixed up. We can do this. Return ID equals other.id. Silly me. So now, if we were to rewrite that function that we did earlier, void func, and we try to do, let's say we make a human ID, human 0, and then a entity ID, entity 0. We get a compile time error because this says you cannot compare a human ID with an entity ID, and that's because the operator overload for the equals must contain the same tag type, and therefore if we make a second human, we should be able to just do human 1, and then everything's fine. We can compile this. So this is just a nice way for us to effectively manage our kind of ID types, and we'll see later on how this kind of plays out and becomes useful. And then lastly, I'm just going to implement a get function so we can actually get the ID out if we actually need it. Let's rename this to IDs because it's a little bit more generic, and we'll put a header guard, include IDs HPP. Like this. Okay, perfect. And then next we want to, like we said, we're gonna make the entity manager, and I'm gonna stick that in ECS. Entity manager. I can't type. Entity manager.hpp, and let's start off with a nice header guard. Include ECS entity manager HPP. Fine. And then we're going to have entity manager. So here, what do we want the entity manager to be responsible for? Entity manager is responsible for, so the entity manager is responsible for creating entities, removing entities, or destroying entities. And that's about it, really. So the entity manager needs to make sure that we don't create too many entities for the specific game or platform. And the reason for that is that you might want developers to kind of stop creating entities after 10,000 entities because maybe your platform is kind of restricted, or you just want to limit it. So let's do that. Let's write these functions out. So create entity, and when we create an entity, we're probably going to want to return it like this. And then we need to destroy entities, and we're probably going to, I mean, we are going to need to tell the entity manager what entity to destroy. And then let's also include entity count, because that's probably pretty useful. Now, how are we going to track the entities? Because effectively, if you remember, when we created our IDs before, we just construct the ID with a type of that. Sorry, we just construct an ID with the type that we specify in the template. So for example, if you want to create an entity ID, we just pass in size t, 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 and then the constructor here takes a t and assigns it here. So I suppose when we want to create entities, we want to make sure that they're unique. And to do that, I'm just going to kind of track, have a variable that we track. Now also, though, if we create an entity, for example, let's say we create 10 entities, and then we destroy entity 7, we've got this free slot now, haven't we? But if we just continue to create entities and let the developer create the next entity by incrementing the entity count, then we're going to potentially have loads of like fragmented space where there are available entities to use, for example, like 7, or entity IDs to use, like this 7, but we're just going to run out of space because entity count's going to reach our maximum entity count, and then we're kind of going to be out of luck. So I'm going to track these kind of destroyed entities in a queue, and I'm going to call this free slots, and we're going to include queue like this. Okay, cool. So let's write the implementation for this. EntityManager.cpp, and we want to include ECS Entity Manager, and then we want to split this off so that we can see. So we want to kind of fill out and populate or implement these functions for our Entity Manager. So, and we're going to have to include IDs.gp2. Entity Manager void destroy. Sorry. Entity Manager destroy entity ID. I can't spell today. Wrong 2. And then entity count. So we've got all of this here. Hash. So we need to fill these functions out. And first of all, what can we do? So we know that we can just return an entity ID, and we can construct it with entity count ++ like this. And this would be fine, right? Because all we're doing is constructing a new entity ID. We know it's unique because entity count can't be created twice because we're incrementing the count every time. And then let's say we go back to this thing where I was saying we were going to destroy an entity, and we want to inform the entity manager that this entity is now destroyed, and all we need to do is go to free slots.push, and we go entity ID.get, and we push that on. So now, let's make this a bit bigger for you. So now when we create the entity, we should probably check that there aren't any free slots. So if the free slots queue, if there are any free slots available, let's use them. So we're going to check this. We're going to say, well, if the free slots queue isn't empty, then we're going to pull the first one, ID index free slots.fronts. We're then going to create an entity ID. Index. We're then going to free slots.pop, and then we're going to return entity ID. Right? So effectively what happens is we check the free slots queue. If it's empty, then we just can go ahead and increment the entity count. If it's not empty, then we're going to take the free slot from the front of the queue, which is an index or an entity ID, and we're then going to, let's change this to ID for now. And then we're going to construct an entity ID with it. We're going to pop from the front because we no longer need it, and then we're going to return that entity ID. Perfect. And then similarly, entity counts, we need to work out the correct entity count. Now, if we just return entity count, this would be wrong because entity count is and will always be bigger if there are destroyed entities. So there's possibly, for example, entity count, there could be 10 entities generated, right? And then we destroy 2. So now we've only got 8 entities, but the entity count never gets decremented. It's just the free slots queue that gets incremented by 2. So we need to take away the size of the free slots queue from the entity count to get the actual size. So I think that should be right. Now, one thing that we should be aware of here is this thing I said earlier about what happens if we only want to allow 10,000 entities to be created. So we need to make limit some kind of ECS constants, for example. So let's just do our trusty header guard again. And we're just going to chuck in some kind of const expr values. Static const expr maximum entity count equals, let's say 10,000 for now. Fix this include. And let's bring that in here. So we should probably go and check if entity count is greater than, what did we call it? Maximum entity count. Is that right? So if entity count is 10,000 and our maximum entity count is 10,000, then yeah, greater than or equal to, then we want to return an error. But this isn't possible right now because we can't return an errored entity ID. So I'm going to pull some files over from EV Engine that I use to handle errors. And that is error and results. Let's put those in here. So this result class, let's close these now, is effectively, if you know stood optional, it's effectively the same thing as that, but it can hold 2 types instead of just 1. And it means that we can hold an error class or an error with a message, and we can also hold an actual type that we want to return. So this one here defaults to const char, but I'm going to change that to error. And then I'm going to also include error HPP here. So you're welcome to kind of look at this later on, and maybe I'll do a video on explaining how I made it and why it's useful. But I'll just show you how I use it, and hopefully it will become clear. And then here, this is just an error class, and all this does is hold a message, but also you can kind of call these accessor functions to say like, is the error good or is the error bad? And if it's bad, then what's the message? So let's change it so that EntityManager can return a result entity ID. Is that okay? That's happy. And then we'll change this result entity ID. And then the thing that I like about this is now we can return an error here saying too many entities. Destroy some, please. But this is really great because you can see it compiles. So we can either return an error or we can return an entity ID. And then what the kind of user can do is they can check the result, and if the result is valid, they'll use it as an entity ID, and if it's not, then they can handle the error however they want to. So I think this is it for our entity manager right now. And if we're happy with that, let's write a little test app so that we can kind of we can show this in action. So make list.text. What are we doing? Add executable ECS test app main.cpp. And then we're going to have to create add library. We'll call this ECS, source ECS, entity manager. And then we also need to add the subdirectory for app. And then this, we need to link it against ECS test app ECS. Is this all happy? Yeah, this is all happy. So ECS entity manager, let's make a main. Let's create an entity manager. And let's create some entities. So result entity ID entity1 equals entity manager.create entity. So here we can create 3 entities. And really what we should be doing is doing entity1 if entity1 bad, then printf bad entity, do something, and then we're just going to return here. But I mean, this isn't going to happen right now because we know. So we're going to create 3 entities. We're going to check their result type, and then let's also print. Let's print each of the entities kind of ID, entity ID, the one.get. Just saying. Yeah, we need to fix the format specifier. And then let's print the size or the entity count. Hopefully this works. It's complaining. This printf format string requires an argument of type. I think that should be fine. Let's double check. If it's not, we'll fix it. Yeah, it's not happy. Let's get return. I mean, that is right, isn't it? Well, first of all, we need this. Been long unsigned. So get data in the free slots. Fix this. And then because entity count, let's also fix entity count. Sorry about this. CMake build. Okay, hopefully this time it's fine. Oh no. What have I done? 40. Ah, yeah. Okay, this time, perfect. As you can see, entity ID 0, 1, 2, and then the entity count is 3, as we expect. Now, let's destroy an entity 1. We need to dereference it because it's not actually entity ID. It's a remember, it's a result entity ID. And I'm pretty sure if you want to, you can actually pull entity ID 1 value. Ah, yeah, okay. So you can kind of pull the value out that way, but we're not going to do it that way right now. And I'm just going to do this to show you, hopefully, that destroying entities works. And then the final entity, let's destroy that. Entity 1, entity 2, entity 3. CMake build. Perfect. So we created 3 entities, each with individual IDs. We have an entity count, and then as we destroy them, the count decrements. And there we go. And also to prove, I suppose, we could, let's just create one more entity. Auto entity ID, no, entity 4 equals EntityManager.create entity. And then let's just print that. Just to prove that we've recycled the entity IDs of the previously destroyed entities. So yeah, the first entity to be destroyed was 0, and then we've gone to create entity 4. We've given it that name, but really its entity ID has been recycled as 0. And there we go. I think for now that will do. And then in the next video, we will continue from here and we'll create the component manager, and that will involve kind of a bit more template work, and the only interface or abstracted interface class that we will use in this ECS. All right, cool. So that's it. The Entity Manager, introduction to IDs, the introduction to error and result type that I use, a small test app, very basic stuff today. But the next video is going to be cool, and we're going to do the component manager. And we'll focus on kind of some tricks that I use to get rid of any runtime type resolution, where we use the ID system again. We'll probably enhance the test app to prove that the component manager is doing what it needs to do. So make sure you stick around for the next video, like, subscribe, whatever you want to do. Please send me some comments. Let me know how the kind of code looks on the screen. And if you're on mobile as well, let me know, because I don't know whether the size works or not. This is the first time I've kind of done this part. So I'd be really interested to hear what you've got to say. And finally, take it easy. I'll see you in the next one. Cheers.